Good afternoon, everyone, and welcome to our weekly Improving Talks webinars, in which top industry experts from Improving share the knowledge for free. I am super excited to welcome you as we conclude this month's Improving Talk series, Secrets of Software Project Success with a Bang. My name is Armando Lopez, and I am a talent management specialist out of the Improving Mexico enterprise. And I am thrilled to present our cool host for today, Josh Harrison. He's the president of Improving's Ohio enterprise, where he's focused on building long-term trust with clients and all stakeholders that interact with the organization. Since joining Improving in 2012, the firm has regularly been recognized by the business community as a fast-growth, best place to work. Josh is a graduate of Leadership Columbus and actively engaged in the nonprofit community in areas related to education and social services. And he has also been recognized by Columbus Business First as a 40 under 40 professional. Whether you're leading a dev team or managing digital transformation, today's session, From Cloud to OmniChannel Fullstack Modernization Case Study, is packed with actionable insights to modernize your stack and accelerate delivery. Very exciting stuff. Before we start, I encourage you to use our Q&A feature at any time during this presentation, and I'll make sure Josh answers your questions live. And now, without further ado, I leave you with Josh Harrison. The microphone is yours. Welcome, my friend.
Armando, I appreciate the generous introduction. So I'm very excited to present Cloud to Omnichannel Fullstack Modernization Case Study. And this was a project that we did for a customer in 2022. And I mentioned that year because it's very pertinent to the industry and what was happening at the time. So I'm going to begin by giving you a little bit of background about the customer. So this was a fast casual pizza chain with about 500 locations around the US. They also did some partnerships with some third-party vendors, some co-branding of their product. Revenues at the time were about 250 million. And they had a growing share of that being attributed to e-commerce and digital ordering platforms. And that was both a secular and cyclical trend. Their online ordering had been increasing over time over the last decade or so, but because of things going on in the environment, pandemic-related buying habits, a lot more ordering was happening online than ever before. And there was definitely a recognition that they had to upgrade their systems. Today, total sales are about 65% online, making it the majority of their sales. And a big reason for that is because of the work that Improving did for them. So let's talk about what we did. Now, this is one of those dream consultant engagements where we built everything greenfield. This rarely happens. The only other time I can think of this happening is something like a divestiture. So the opposite of a merger, where a company separates and you build everything from the infrastructure all the way up to the application layer. And that's exactly what we got to do on this project. And the reason for that is because they realized that their existing legacy architecture was so out of date that they needed everything to be built from scratch. So couldn't have been more of a dream engagement for our delivery teams. So we did everything from the cloud infrastructure, the databases, the services, the website, the mobile apps, and all the back-end reporting and data analytics around it. And that's why this presentation is called Full Stack Omnichannel. You can see the various layers of the stack there on the right. It's really cool when you can start completely greenfield and build out basically the entire infrastructure of an e-commerce platform. Now, we didn't build out the ERP or inventory systems or anything that was internal, but everything that the customer touched, we built out. And I think it was also sort of this Goldilocks project where the customer was just big enough that they had budget for it, but not too small that they could have used like a Shopify or some sort of SaaS platform to meet their needs. The need was great because of what was going on in online ordering, and they had the budget for it. So because all of those three things were met, they really viewed us as the strategic advisor that could get them what they needed. I'm going to talk a little bit about what was going on in the industry at the time. One of the great things about having competitors that are publicly traded is you can see how the market reacts to their moves. And because of public disclosures, they have to tell you what they did in the past, what they're doing now, and what they plan on doing in the future. So as I mentioned, we came into this project in 2022. However, we were able to look at what the major dominant competitor in the market was doing in 2021. So this chart is from January 2021 until January 2022. And you can see the significant upward trend in the stock price there. They had this is Domino's publicly traded information. So they had revenues increase of 11%. 75% of their orders came through a digital channel, and they had 12% net margins. And because of that, and reasons that we will discuss in a minute, their stock price was up almost 50% in 1 year, and they added 3 billion of market cap to their enterprise value. Now, I point this out for those that are selling or delivery teams. If you can convince someone that's to spend a few million dollars will get them a few billion dollars of value, it's an easy yes. It's an easy decision for them to make. So, being able to demonstrate that value is sort of how we got in the door and got the conversation going and saying, hey, here's what some of your competitors are doing. Here's what it's doing to their value. Here's how much more in online sales they're doing. Are you interested? And so as you looked at the K1 annual report of Domino's, it quite plainly spelled out why they did so well, and industry analysts pointed to this as well. So it was really the reason that their stock price was up 50% was largely because of their tech-led brand perception. And a common quote you would hear from industry analysts was, they're a technology company that sells pizzas. And so our customer wanted to be in that same position. And if you went into that 10K annual report, there were 5 things that they stated that got them to where they needed to be. Now, at this time in 2021, there were many fast casual places that didn't even have online ordering, and they had to rely on DoorDash and Uber Eats. And those companies did not do as well financially as a result. As we're well aware, the third-party DoorDash, Uber Eats type companies take a significant amount of the revenue and profit. So the 5 things that were outlined in the annual report is mobile ordering, both native mobile apps and web apps, chatbot ordering. The idea of digital rewards are making a customer more sticky, allowing them to spend more and incentivizing more on digital ordering through rewards. And then some real-time inventory management and a little bit of AI ML in the supply chain management. So that's what put Domino's ahead. So when we looked at what our customer, now we're switching gears back to the customer we worked with. When we looked at what their environment looked like, this is a basic snapshot of it at kind of the 30,000 foot level architectural diagram. They had an e-commerce site. They had an iOS app that was written in Objective-C. They had an Android app that was written in Java, and all of these things interfaced with a service tier layer that was very monolithic. Think heavy middle tier that's doing all sorts of batch processing and moving things between systems, moving things between databases, making sure that the thousands or so point of sale systems are up to date with local pricing. And then they also had physical on-premise servers farm that they had to manage. So there's a lot going on there. And none of these individual solutions were bad solutions. They were probably best of breed for their time. But as time went on, as a decade of great solutions were put in place, the sum was not greater than the parts. The iOS app was amazing, but it was different than the Android app, and it was different than the e-commerce site. And the way that they all interacted with each other did not make sense from a strategic technology standpoint. So what was needed was an understanding of what should that full picture look like and how can we build it? So this is where the opportunity to build everything from scratch came in. So let's talk about some of the challenges with the architecture that you see here. So there's a lot of complexity to it. You had to maintain an on-premise data center, a lot of point-to-point data integrations. It wasn't all real time. It was overnight batch processes that had to move data from source to source. And that data wasn't always consistent. You might look at something in one store or on the website or on the iOS app or on the Android app, and it was all different. The user experience wasn't the same, and the data itself wasn't the same. And when you have this many disparate platforms and languages, you need to employ a very broad tech team that understands a lot of different languages and platforms. So in the diagram that I just showed you, the team had to know Java, Kotlin, Objective-C, PostgreSQL, JavaScript, and PowerShell. That's a hard staff to source, and they had some challenges. And it also creates an unnecessarily large and budget constrained team. They also had very limited capabilities for DevOps, monitoring, scaling, and deploying. And these are known limitations with physical data centers. So whenever we do a big project like this, I like to think through what are the strategic goals or what are the guiding principles. Whenever we have to make a decision, we want to understand what are we actually optimizing for. So we identified four at the beginning of this project that would guide the team in making their decisions. The first is to move to a more dynamic infrastructure that reduces complexity around feature enhancements, which makes the developers more productive. The second is to standardize the tech stack and programming languages. Can we get it down to one or possibly two programming languages? Third is to leverage cloud capabilities inherent in the new architecture, which includes DevOps, automated testing, monitoring, deployments, and analytics. We also wanted to, and this was really this last goal here is really the bottom line of why we did everything else. We wanted to enable a development roadmap that shifted investments from operational capital to aspirational capital. They were spending a lot of money just keeping systems going, just keeping them operating. They wanted to spend capital on new features, new investments, new ways of generating revenue. And the new platform we put in place helped them do that. So let's talk a little bit about this phased and iterative approach. There were 6 different phases to this project. Each of them had dependencies on the previous one, but they all could have been standalone phases. And we presented them with all 6 phases, but said you can get off the bus whenever you want. So if you're done at phase 3, you can say, we found enough value here. We don't want to spend any more money. We're in the cloud and we're just going to take the benefits of that. Or they can move on to phase 4, 5, and 6. So we ended up doing all 6 phases, but we allowed them the ability to stop at each phase, and they would have realized value at each of those. It's sort of I think of like agile programming. When you're doing agile, you do iterative on a specific week of development. We wanted to take this agile approach at the program level and apply it to each phase. It's also a great way to build trust with a customer. So if you do a great job on phase 1 and they see the value and they see what you delivered as being high quality, they're more likely to bite off on phase 2. Here's a quick high-level Gantt chart of the project timeline. We first moved the application servers to AWS. Once it's in AWS, we leverage the AWS cloud capabilities. Once those cloud capabilities are well developed and understood, next we replace the point of sale system with a cloud service called Aloha that is provided by NCR, who was their point of sale provider. Those first 3 are really the infrastructure pieces of the stack. The next 3 are the application layer. So once the infrastructure layer was in place, we were able to then replace integration layer with microservices, and we'll talk a little bit more about what that means. We then could update the website and connect the website with those microservice layers. And then once the website was updated, we could consolidate the mobile apps as a progressive web app. So as I said before, each of these layers has dependencies, but you could stop at any of those layers and achieve the value you're looking for. All right, let's talk a little bit about each phase and what we did. First up is move the application servers from on-premise to AWS cloud. Now, there could be an entire presentation given on what is needed to move to the cloud from on-premise. So I'm going to try to condense that to about 5 minutes or less and talk through what we did for this customer to get them to where they were and where they needed to go. First is just understanding what applications there are and what their level of complexity is and what's needed to move them from a physical server farm onto the cloud. And when you do that, you oftentimes will categorize the type of application it is or the type of component that it is. And they tend to fall into one of 3 buckets. The first is an infrastructure as a service. You may know this as lift and shift. So just taking the physical machine, turning it into a virtual machine, and moving it into the cloud. That is the absolute easiest way to move something into the cloud. There are some downsides to it. You can't take advantage of all the capabilities of the cloud. It tends to be a little bit more expensive because you're running a full virtual machine versus an individual service. So when we could and when it made sense, we wanted to retrofit applications and components for a platform as a service, which is the second option there. Now, it takes a little bit more work up front to do that. You have to analyze the code, understand what it's doing. Oftentimes, as you see on bullet point 3 there, you have to rewrite, rebuild, or replace some of the code and some of the functionality before you move it to the cloud. So what we essentially did in that first phase was determine what's the cost of moving it from an IaaS service to a PaaS service. Is the barrier too high to turn it into a PaaS? Okay, then we'll make that component an infrastructure as a service. Is it worth the benefit to move it to a platform as a service? If so, we'll do that. So we spent a few weeks just analyzing what could and couldn't be done and how we were going to move it. And that's pretty standard for any cloud migration. Once we understood what the inventory of applications were and what could be moved, we then moved on to designing the cloud architecture. And this is really about containerizing different components, using things like serverless functions. And these first two things really just mean moving up in the layer of abstraction. I think it was Dijkstra, the computer scientist, who said all computer science problems can be solved by one more level of abstraction. And that's really what you're doing when you're moving things into a cloud. You don't want to worry about the physical infrastructure. You don't want to worry about patching. If anything, you don't even want to worry about the application platform it runs on. You want to just tell a service, this is what you're supposed to do, and this is how you're supposed to do it. So those first two bullet points under design cloud architecture are really about moving as far up the abstraction layer as possible. Bullet point 3 and 4 are really about scaling, and the way that you scale in the cloud is by scaling horizontally. The way we had traditionally scaled in the server farm, physical server eras is to add more horsepower to a server. That's called vertical scaling. To get the most out of cloud, you really want um, less computers you want more computers doing less work. Um, and microservices is a sort of a application development way of doing that. So you try to architect your application so that there's lots of redundancy, lots of um, lots of um, lots of federation happening, so that the processing can be done on many computers at the same time. Lastly, once all the applications are moved over, you then need to move the data over, and then you decommission the old sites. So this was about a 6 month period of moving from on-premise to the cloud. So that was phase one. And once that was complete, we could then start actually realizing some of the benefits of the cloud. So some that came right out of the box is dynamic scalability. You can push a button and spin up another server. Why does this matter? Imagine you are selling pizzas and you sell them throughout the week, but when Friday at 5 o'clock hits, you have 10 times the order volume because why not? Friday's pizza nights. Everyone's tired of cooking at home and they just want to make the kids happy. And so everyone's calling at the same time. You might need 20 or 30 servers to service that amount of order volume, but you don't need that Monday at 2 p.m. So dynamic scalability gives you the capability to spin up 30 servers for a couple hours while you're taking in that increased order volume, and then decrease it down to just a few servers when the order volume drops. And you can set this up in cloud providers to do this dynamically. So as the traffic starts to pick up, you don't even have to push the button. The button gets pushed for you. So that when Friday at 5 o'clock hits, your server farm just starts getting larger and larger. So that was a huge realized benefit from day one once we moved them into the cloud. Next up is enhanced security. Because you don't have to worry about patching and um, a lot of the other daily activities that happen on the security front, your environment's going to be much more secure. I'm not saying you don't have to think about security at all, but let's call it 80% of it is taken care of for you. This is also true for monitoring. The cloud providers, AWS included, have very robust monitoring to tell you when an attack is happening, how many users are on your site at any given time, how many orders are happening, what the order volume is, what the dollar amount is. There's all sorts of levels of granularity that you can get in monitoring that benefits both the technical side and the business side. And then really the bottom line here is that results in less maintenance. You're not spending time worrying about replacing hard drives or patching servers or moving logs around. All of this is taken care of for you so that you can worry about much more important things. Okay. So those capabilities come in the box with cloud services in AWS. But I think of cloud services as sort of a digital Swiss Army knife. There's all sorts of things you can do. And when you flip it on, you're really only using about 5% of it. So we spent the next couple of months, so month 4 and 6, developing some of those more advanced capabilities of the cloud.
Josh,
Yes.
we have a question for
Oh,
you.
bring it on.
Just as you finish, what went right by this moving, it says, did operating cost go down by moving to the cloud?
Yeah, that's a great question. And I always answer this with a fairly large asterisk because the answer is sort of and yes. And so sort of is immediately it moves from capital expenses, like think big, heavy infrastructure, upfront costs, to operational costs. So you don't need that large outlay of servers like you would in a traditional server farm. Um, but there still is an operating cost. And I think there's this misconception that if you move from physical servers to in the cloud, you're immediately going to get cost savings. And that's absolutely not true. What happened with us on this project and what tends to happen is you start seeing how those servers are used and you start optimizing for it. So you start looking at what processes are running long, what data calls are taking a long time. And improving actually provides this as a service. We can look at your cloud usage and bring down the costs. So I would say on day one, when we flipped this on, the costs were maybe a wash. But as we started to develop more of the cloud capabilities and understood the analytics and reporting and what resource intensive things were happening, we then brought the cost down significantly. So initially it was sort of maybe, but within 2 or 3 months, there were significant cost savings. That's a great question and one that I'm always very careful to explain to customers because oftentimes they think, well, on day one, my bill is going to be lower. And that's just not always the case. In fact, it's rarely the case unless you bring in a team that knows what they're doing to bring those costs down.
Yeah, that makes sense. Thank you, Josh.
Thanks, Amando. All right. So, what are some of the more advanced capabilities that you can use in the cloud? So, DevOps, this is the idea of development and operations being synthesized, making the developers more productive, making deployments happening more often. Automated testing. So, when a developer writes new code or changes existing code, you'll know right away whether it's a breaking change or not because automated tests are running constantly as development is happening. Additionally, automated deployments, the ability to deploy by pushing a button or scheduling it, not even having to push that button. Um, and that ties into site reliability, and I won't go too deep into that. And then this idea, and this is really why we do these other things. Typically, in more traditional organizations, deployments happen every 3 or 4 weeks. It tends to be an event. Oftentimes, it happens late at night because you're doing such large deployments that you want to make sure nothing breaks. When you take advantage of some of the more advanced capabilities of the cloud, daily deployments are possible. So this means making very small changes, deploying them throughout the day, measuring whether they're working or not working, i.e., whether the customer is liking that change, whether they're buying more pizzas, whether they're moving farther and farther into the sales funnel, and then the ability to do A/B testing and seeing which might be working better than the other and making those adjustments. It allows the business to make more and more changes and observe the customer before waiting 3 or 4 weeks. It also makes breaks less frequent because you're making smaller changes instead of an all or none approach. And then lastly, data analytics. So the ability to, once you deploy the software out there, get really good insights about how people are using it. Where is their drop-off point? Are they leaving things in the cart because they're confused? What are ways that you can upsell based off of the flow of the sites? The overall benefit of this is that there's shorter development cycles, there's faster deployments, and there's less errors. It's good for the tech side, it's good for the business side. All right, once we had the cloud in place and we started leveraging some of the advanced capabilities, it was then time to replace the on-premise point of sale systems with Aloha Cloud. Um, because there are about 500 locations, let's assume about 3 point of sale systems per location. You're looking at about 1,500 point of sale systems that are all synchronizing data. Think a Windows server station in every single restaurant that's getting pricing data from some sort of centralized database and synchronizing across all of the point of sale systems. This is a very expensive process. It's very error prone. It's very time consuming. And so I won't go deep into this because improving didn't do this implementation. We coordinated with NCR, who was the point of sale provider. But what we had to do was make sure that as things moved into the Aloha cloud, our systems integrated seamlessly with it so that you could then get that data in real time. So there was no more batch processing, no more moving CSV files back and forth. Everything was real time with a centralized database in the Aloha cloud. And so what that meant is that everything was in the cloud at that point. So it allowed for real-time integration, centralized configuration, and centralized data. So once everything was in the cloud, it made it so that the service tier layer could be written and pointing to a set of clouds. It also allowed for the website and the mobile apps to be pointed to one cloud. So once everything was in the cloud, that was really the infrastructure base to start doing more interesting things on the application development layer. And we'll talk a little bit about the application layer. First thing that we did after the infrastructure was taken care of was replace this monolithic middle tier integration layer with a more elegant microservices architecture. And I talked before about scaling horizontally. Microservices is this idea applied to the service tier. So you have an API gateway that all calls come through, and they get routed to one of the microservices based off of what is needed. So I'll give you one specific example. Let's say I want to get the price of a piece of pizza with various toppings. I would call into the API gateway, which would then call into a pricing service. If I wanted to change that pricing service, I could develop and deploy just that pricing services, again, doing daily deployments without affecting any of the other services. So if there is an issue with it, it's relegated to just that service. So this gets back to the idea of both scaling horizontally and allowing for daily deployments and smaller changes to happen at once. So what are the benefits of doing, I alluded to some of these, but what are the benefits to doing microservices? You get distributed versus monolithic architecture. And basically, anytime you're in the cloud, you want to err on the side of distributed. Monolithic means it doesn't scale easily, and the only way to scale it is to add more compute power, which is expensive, versus adding more application logic. Shorter development cycles because you're deploying smaller units of work. That API gateway is important because it allows for traffic management and scalability. You can measure what calls are coming in. You can determine we need more microservices on the pricing engine, but less on the ordering service. So it gives you a lot of information on how your application is being used. Okay. So this is kind of the boring stuff and I say boring stuff because the delivery teams love this stuff, but it's nothing that the customer actually sees. So everything we've talked about so far is basically under the hood. There's no UI. Everything is serverless functions. So now we get to the more interesting piece, which is what the customer interacts with. So now that we had all these other layers in place, and after we had built trust between layers 1 through 4, it was time to update the website. And we put a lot of thought into the website because we knew the mobile apps were a challenge in the past. And if we could do the website right, it would make mobile much easier. So the first thing that we did is think through mobile first. About 70% of all web traffic is on a mobile browser versus a traditional browser, which means we built the site and designed it with mobile, assuming that the customer was using mobile. And if they didn't, it would fall back to a traditional browser. So that meant two things. One, it meant that it was a responsive website, meaning it looked great on a phone and also a tablet as well as a PC. So depending on the size of the browser, it would change what the components look like. This second part is very important, and it's one, it's much more than going beyond responsive. Everyone's been doing responsive websites for about 10 years now. This next piece is about creating your website reusing code on a website that will fit a mobile app. So as we were developing the website, we knew that the components that we were building for the website would be used for the iOS and Android applications. I'll get a little bit more into how we do that, but just realize that when we were writing the code, we didn't want to box ourselves in, and we knew we wanted it to be an elegant solution for when it does go to a native app. We used a platform called React, which is a JavaScript framework for structuring your web applications. There's another framework called React Native, which I'll talk about as we get into the mobile piece, that helped us out a lot and gave us some huge advantages. We also wanted to think through performance optimization. Since most people are using their phones that have a little bit less CPU power and are often disconnected from the internet, you want to prevent that lag. And so React helps a lot with that as well. And then we also wanted to think through automated testing and automated deployment. So we weren't just thinking through the development and the code and what the customer sees. We were thinking through how do we set up those pipelines to make it so that automated testing and deployments happen innately. Okay, so I talked a little bit about the website and how we made it component
Josh,
architect. Yes,
sorry to interrupt. We have another very interesting question,
good.
and it says, speaking of the new website, did online sales increase as a result of this?
Another asterisk and another somewhat long, longer answer than needed eventually. So on day one, it's not like web sales grew by 20%. But on day one, once we flipped everything over, including the mobile apps, it allowed the the business and the tech team to make rapid changes. So if they wanted to set up a rewards program, they could do it quickly. If they wanted to create a promotion on Thursdays or during a high state football games, they could do it quickly. So they could do a lot more in a more nimble way, which then led to more sales. So I want to be careful when I say, oh, the new website led to more sales. It did, but only because the architecture was dynamic and agile, so that they could make all sorts of changes and feature enhancements going into the future, which then drove revenue.
Okay, okay, that's very interesting. Thank you, Josh. No more questions right now.
All right. Okay, so now that we had a cloud with microservices and a website, we then could spend the last 2 months of the project and only 2 months building the iOS app and the Android app. So why did it only take 2 months? It's because we could take 98% of the code that we used for the websites, these React components that I talked about, and port them over directly to React Native. And when I say 98%, I basically mean everything except for some of the payment mechanisms that are specific to a phone. So think like Apple Pay, where that wouldn't be on the websites, and some of the other very specific native phone features. So 98% of the mobile apps were done. And it wasn't just that we were copying code over, they're literally sharing version control so that when an update is made on the website or on the mobile app, it automatically appears on both. So we had one code base for web, iOS, and Android. Contrast that with when we had an HTML, JavaScript, CSS code base for the web, an Objective-C code base for iOS, and a Java code base, Java Kotlin code base for Android. That is significant reduction of complexity from a developer standpoint. It means you could basically hire a team of Java, JavaScript, HTML web programmers across all three channels. So it made the omni-channel much more seamless, much more consistent, and much less expensive to maintain. And it just created a consistent user experience across everything. Prior to that, things get out of date. A feature might be added to one native mobile device, but not the other. It might be added to the web and not to mobile. Over time, it became a little bit unwieldy. This made it so that everything was consistent and would be consistent going into the future. So we've completed phase 6. We've developed the cloud. We've created microservices. We've built a new website, and we have completed the iOS and Android apps in an 18-month period, by the way, with a team of about half a dozen people. So we had 6 people in 18 months that built an entire e-commerce full stack platform from scratch. So this is what it looked like before. As I mentioned, there's lots of different types of platforms here, lots of synchronization issues, lots of coordination, lots of managing physical architecture and infrastructure. And we moved to something much more elegant, much more seamless. Keep in mind here, so basically we have a mobile app and an e-commerce site that's talking to one cloud provider Behind that cloud provider is the point of sale cloud that the mobile app and e-commerce site don't even know about because they're talking directly to the AWS cloud. So that's abstracted away. Now keep in mind that the e-commerce site and the mobile app share 90% of the code base. So even though you see kind of four boxes here, there's really only one and a half boxes you really need to pay attention to. You need an AWS engineer or a team of AWS engineers that understand the cloud. And then you need a person or a team that would understand JavaScript, React, and its cousin React Native. So it's an incredibly simplified, elegant team structure that you have in place that you can move people across these boxes. Okay. So that's all that we completed for this customer in an 18-month time period. I love this case study because the business value is interesting, especially in the year 2022. Uh, it was obvious that focusing and investing on technology would lead to higher revenue, higher margins, higher enterprise value. And the tech, it was always fun doing a greenfield project and building all sorts of components that interact with each other in an interesting way. So what questions do we have, or what further questions do we have?
Talk about a great makeover. Thank you for sharing that, Josh. And speaking of that, what's next for the customer on the technical roadmap after all these crazy and amazing changes you did?
Yeah, so I think this is what excites me the most. They now have a platform where they have the ability to change as much as they want, as quickly as they want. So prior to this, if they wanted to make a change to the website, there was a very bureaucratic process. Fill out a form, prioritize which changes make the most sense, throw it over the fence to the tech team, and in 4 to 6 weeks, you would see your change on the website. Now, it's not atypical even today for a lot of tech environments to work that way. But now the business has quick turnaround on any item they might want to see. And so now they're looking at things like chatbots, implementing AI and figuring out what the customer is doing, what ways you can offer them. Maybe a chatbot pops up and says, "Hey, would you like this new offer?" Or maybe direct them to a different type of promo page based on what they're adding to their cart. So they're able to experiment a lot more with the customer journey and use AI to make that journey more compelling. So I think data analytics and AI is the frontier of what's next for this customer. And we're in conversations with them right now about that.
Okay, keep us posted on that. Amazing. And I also got another one for you. It says, did the team get a pizza party at the end of this project?
No,
Speaking of pizza.
I think they were a little sick of eating pizza at the end of this project. We would often order as test pizzas through actual stores and then have them delivered to our office when we were working on this site. So it wasn't necessarily one individual pizza party, but we had pizza weekly when we were working on this customer.
Okay, okay, fun. And we don't have any more questions from the audience. I don't know if you want to share any closing remarks before saying goodbye, Josh.
No, I think one of the things I loved about this project, and I'm going to go back to this slide here, is the way we structured it is it inherently built trust through each step of the process. So steps 1 through 6, at each of those steps, we could have stopped and the customer would have seen value. And because they kept seeing value on each of those steps, there was more and more buy-in and they wanted to work with us more and more at each phase. And, our company is really about building trust. And I love when we can build that into our project approaches, our statements of works, the kind of work we do and the way we intend to do it. So I want others thinking about how do you build trust incrementally and have it lead to something that turns into something big.
There you go. The keyword trust here at Improving. Thank you, Josh. And that's all for today's Improving Talk session and for this month's series. Big thanks to our awesome audience, but especially to Josh Harrison for such an insightful presentation. It's been awesome learning from you. And coming up next week, a brand new Improving Talk series, Bleeding Edge Technology, Unlocking the Future of Human Innovation. Join us for this 4-part webinar series that delves into the most exciting and transformative technologies of our time, Bleeding Edge Technology. Our experts will guide you through the latest advancements in quantum computing, artificial intelligence, neuromorphic engineering, and the integration of these technologies into your organization. You don't want to miss it. Until next time, everyone, have a great rest of your day. Thank you again, Josh.
Thank you, everyone.